The iDropWebBrowser can be used to execute rules. The original client to the lifetime library is the iDropWebBrowser. This provided a standard web client for loading files, adding metadata, browsing collections, setting access controls, sharing files, and executing rules. The web interface is available at lifetimelibrary.ils.unc.edu. The challenges with this interface were related to portability across the wide range of operating systems and Java library installations, and an extension was needed to the system to support browsing of virtual collections, which led to the development of the cloud browser. You can store a rule in the lifetime library, edit the rule, and execute the rule. To load a rule, log into your account using your username and password. Click on Browse to see a list of your collections. You may want to form a sub-collection to hold all of the rule examples. You can create a sub-collection and then click on the sub-collection name to start loading rule examples. Each rule file that is loaded into the data grid should be a text file that ends in the extension .r. When you click on a rule file, the system will display a set of operations that can be performed. The last item in the list is rule. Click on the Rule tab. This will display the rule, display the input parameters, and provide a section for displaying output from running the rule. You can reload the rule if it does not display immediately. You can edit the text and then save the changes with update. You can then run the new rule. The rule display window is shown here. The top window lists the text of the file. If you do not see the text, click on Reload. The middle window lists the input parameter names and their values. The bottom window lists the output parameters that are listed in the rule output line. The rule will be run when you click on Run Rule. The output is listed in a standard out window. Errors that occur when executing the rule are listed in a error out window. Note that the rule must be stored in the data grid for the rule execution to take place. Also note that a file is identified as a rule if it has the extension .r. Edits can be made on a rule at any time. The edits will be saved when the Update button is clicked. A user can make edits, run the rule, examine the output, and iterate until the rule behaves correctly. The simplest change is to add a write statement. Write line standard out, adding a write statement. This will print a message to the screen that will be seen in the output section. Take 7 minutes to complete exercise 40. Execute your rule for adding two numbers from the iDropWeb client. Modify the rule to add a third number to the total. Modify the rule to multiply the result by 2. Please load your rule file into the lifetime library in the subcollection class INLS 624 by the end of today's class. The Centre de Calcul del Institut National de Physique Nucléaire et de Physique des Particules, CCI and 2P3, is a research center in Lyon, France. The center manages data collections for multiple international projects. This is a production service that has been running for more than 10 years. The IN2P3 is one of the largest data grid centers in the world. The international collaborations span multiple disciplines, including multiple countries, and generate massive access demands. Currently, 23 data grids are managed, with each data grid supporting a different user community and implementing potentially a different set of management policies. User accounts are given to researchers who manage datasets for a community. Much of the data are publicly accessible. Thus, the number of user accounts is relatively small, 469 users, organized in 41 user groups. The user demand on the data grids is massive, with up to 800,000 accesses per day. The sustained load is over 6.4 million accesses per month. This requires a support infrastructure that is fault tolerant, supports failover between multiple servers, and load levels across multiple servers. The size of the collections is about 80 million files, totaling nearly 10 petabytes of data. The ingestion rate is up to 30 terabytes per day. This is a sustained network traffic rate of 347 megabytes per second. Note that while data are being loaded into the system, on average 213,000 accesses are proceeding in parallel. The disciplines using this center to manage collections include physics, biology, biomedical applications, the arts and humanities, and computer science. These represent projects in 14 subdisciplines. The high-energy physicists typically store the most data from the experiments at CERN and the Large Hadron Collider. However, the amount of data generated by geneticists is now becoming almost as large. The collection sizes for the arts and humanities tend to be the smallest. Digital document storage is usually the smallest. The IN2P3 makes aggressive use of the ability to delay rules for later execution. Each file that is loaded into a collection is automatically replicated to minimize risk of data loss through a delayed rule. It is typical to have tens of thousands of outstanding delayed replication rules queued for execution. The system processes the queue on a first-come, first-served basis. However, administrative rules to correct problems have to take precedence. An example is disk cleanup to create space in a staging area for new files. The oldest files are removed from the disk cache to make room for new files. To improve network performance, small files are aggregated into containers, such as a tar file, before download. This helps the network utilize the entire bandwidth capacity. Otherwise, small files would only fill part of the network pipe, causing additional latency during transmission. To minimize the load on tape archives, the IN2P3 uses versioning of small files as a form of backup. Multiple copies are kept on disk instead of writing one of the copies to a tape archive. The IN2P3 uses report generation rules to track storage usage, the number of users, and the number of files. Information is also maintained about the load on the system and used in resource planning to ensure the system remains responsive to user requests for data. The heavy load on the IN2P3 resources requires continuous assessment of the scalability of the data grid software. There are multiple possible choke points: the network bandwidth for loading data, the storage bandwidth for writing data to storage, the number of simultaneous users and the associated memory requirements, the performance of the database. The IN2P3 has to periodically optimize the index of the database to ensure that queries are handled quickly. This typically occurs every week. A second challenge is the incorporation of ever-improving storage technology. With cloud storage, a researcher may have stored their data in a personal cloud storage vault. There is increasing demand to be able to access personal cloud storage using the same mechanisms or clients that are used for accessing the IN2P3 storage vaults. This requires the ability to associate access controls with the storage system. A researcher would decide which other researchers would be able to access data in their cloud storage vault.